Hey guys, so today we're going to be doing the last of our cycles, the water cycle. Now, I'm sure you guys are all super familiar with the water cycle. You've learned it a million times by now, but I do think we're going to be adding a term or two that you're not familiar with. We're also going to be looking at some of the properties of water, and then just like with all of our cycles, looking at how humans have impacted it. Okay, so the hydrologic cycle is just another term for the water cycle. Of course, you need to know all the different processes, be able to identify them from both descriptions and an image, have to explain the properties of water and how that helps water function in terms of biology, and then, of course, our human impacts. So these are the different processes that you're going to need to know that describe how water moves through the biosphere. So evaporation, transpiration, condensation, and precipitation. Those four you're probably familiar with. The last one is collection, which includes terms like percolation and runoff and subsurface outflow. So evaporation is obviously just the movement of water molecules from the hydrosphere, where they're in liquid form, to the atmosphere, where they're in gas form. Transpiration is a similar process. It's just the evaporation of liquid water from plants. So the liquid in plants becomes water vapor, which goes out into the atmosphere. Plants take water in at the roots to be used in the leaves for photosynthesis, and then during that process, the water can evaporate from the leaves to go out into the atmosphere. Condensation is when the gas form of water vapor in the air turns into liquid water that is still in the air. That's when we start seeing clouds, is when we have the condensation of water vapor into liquid water. And then once enough of that liquid water has built up in the clouds, it can fall back to Earth in the form of precipitation. So precipitation, which can be both liquid or solid water, is just the falling of water molecules that are either solid or liquid from the atmosphere back down to the ground. And then collection, this is the term that might be new to you. This is just when liquid water that is on Earth's surface collects in large bodies of water, including oceans, lake, and groundwater. And this involves three different processes: runoff, percolation, and subsurface outflow. Runoff, we've already talked about in like the phosphorus cycle and stuff. This is when water moves across the surface of the ground in like streams and rivers and stuff like that until it gets to a larger body of water. And runoff tends to carry like soil and fertilizer and stuff like that with it. Percolation is when water that's on the surface of Earth sinks down through the soil or other porous material. This process often involves leaching, which we also talked about in the phosphorus cycle, where different nutrients that are in the soil get brought down until they reach like a groundwater supply, so a supply of water that's underground. Percolation is also called infiltration. And then the last term in terms of collection is subsurface outflow. This is similar to runoff, but it occurs underground. So this is water flowing underground, usually from a groundwater supply to a large body of water like an ocean or something like that. Okay, so this is all the different processes you need to know. Evaporation, where water goes from the hydrosphere to the atmosphere. It then condenses into clouds and stuff like that, falls down in the form of precipitation. Transpiration is just evaporation from the trees. And then our three different types of collection: runoff, where water runs across the surface of the ground, like in a river or something, until it reaches a larger body of water. Infiltration, also called percolation, where water sinks downwards through the soil until it hits a groundwater supply. And then subsurface outflow, where water is flowing under the surface of the ground until it reaches a large body of water like an ocean or something. Okay, this is just the exact same process being represented here. So again, evaporation, liquid to gas, condensation, where the gas becomes liquid in the air, falls down in the form of precipitation. We've got the surface runoff here, which is one type of collection. We have infiltration, where water is sinking down from the surface of Earth into the groundwater, and then that groundwater flowing outwards to the ocean would be our subsurface outflow. And of course, we also have the transpiration in there from the trees. All living things do need water. It is often called a universal solvent, which is why it can be used in so many metabolic reactions that happen in your body. A lot of the molecules involved in these reactions need to be dissolved in order to react. And so water, being a universal solvent, is able to dissolve most of these substances. It is also a reactant itself in many of these metabolic reactions. Most of your cell's cytoplasm is water, so that molecules can be transported through it more easily. It also helps to reduce temperature fluctuations in different ecosystems. Ecosystems that are closer to large bodies of water don't have as extreme temperature shifts, both in the winter and in the summer, because water doesn't heat up or cool down as quickly as the surrounding air. And so Earth as a whole would be a lot hotter during the day, a lot cooler at night, if it wasn't for our large oceans, because it can absorb a lot of the thermal energy during the day and then slowly release it at night. So it absorbs the energy during the day so that the Earth doesn't heat up as much, and then slowly releases it at night so we don't cool as much. Water does have some unique properties that make it special compared to a lot of other liquids. One, it has both cohesion and adhesion, which we talked about when we were talking about plant biology in Science 10. Water is also a polar molecule, which we also talked about in Science 10, and water will form hydrogen bonds with other water molecules. So cohesion and adhesion, just as a reminder, cohesion is the ability, I'm saying this backwards, cohesion is the ability of water molecules to stick to one another. They're like cooperating with one another. Adhesion is when water molecules stick to the outside of their container, or like the outside of a xylem tube, for instance. And plants couldn't function without these two properties of water. And then water being polar, that has to do with the fact that the oxygen atom is going to be slightly negative. The two hydrogen atoms are going to be slightly positive, and that is because of the unequal sharing of electrons that takes place in the covalent bonds within water molecules. The oxygen atom has a higher electronegativity than the hydrogen atoms. That means that the oxygen atom has a stronger pull on the electrons in the covalent bond. So those electrons in it with the oxygen more than with the hydrogen. And so because of that, the oxygen ends up slightly negative, since the electrons are negative, and the hydrogen, which doesn't get as much of the negative electrons, ends up slightly positive. This polarity is what allows water to be such a great solvent. It can dissolve other polar substances, can also dissolve ionic compounds, because the poles of the water molecule bind to either the ions in an ionic substance or the poles of other polar molecules and can pull them apart, essentially. And then hydrogen bonding is a type of bond that can occur between different water molecules as well as between other types of molecules. Essentially, a hydrogen bond is a type of intermolecular bond. Intermolecular bond meaning between two different molecules. Anytime you have a hydrogen bonded to a nitrogen, an oxygen, or a fluorine, that is going to create the potential for a hydrogen bond. So any molecule that has a hydrogen bonded to NO or F has the potential to hydrogen bond to another molecule that has that same property. Essentially what happens, and you can see it up here, is that the slightly negative oxygen is going to form this hydrogen bond with the slightly positive hydrogen bond. So you do have to have a slightly negative and a slightly positive on two different molecules forming this hydrogen bond. This is what allows water to have such a high boiling point, especially for a covalent substance, because this hydrogen bond is the strongest type of intermolecular bond, and that would have to be broken in order to boil water, to get those molecules to separate out into different gas molecules. Hydrogen bonding also allows water molecules to keep a really rigid arrangement when they freeze. This is actually why water is one of the few liquids that expands as it freezes, because these hydrogen bonds really hold the different molecules apart from one another when they're frozen. That's what this is showing down here. You have these hydrogen bonds that are holding the water molecules in a really rigid ice shape. That's really important because it means that ice is less dense than liquid water, which allows it to float on top of liquid water, which is the only reason that aquatic ecosystems are able to survive throughout winter months here in Canada and in other cold climates. And up here, this is how we represent intermolecular bonds like hydrogen bonds with this like dashed line. So we have one water molecule right here with its slightly negative oxygen and slightly positive hydrogens, another water molecule here, and then the slightly positive hydrogen forms this hydrogen bond with the slightly negative oxygen. Okay, so let's finish off by looking at some impacts of humans on the water cycle. We have increased the rate of evaporation because of deforestation and urbanization. When we deforest an area, the soil is no longer protected from sunlight, so water evaporates from the soil more quickly. And with urbanization, by creating all of like these large areas of like tarmac and like dark buildings with like shingles on the roof and stuff, it creates a very low albedo. So a lot of solar radiation gets absorbed into that area. And the more solar radiation and energy absorbs, the more it heats up and the more evaporation happens. We also get something called urban heat island effect because of urbanization. Essentially what happens is because of the higher rates of evaporation in urban areas, all of that water evaporates, it then condenses in the atmosphere, and you get more precipitation downwind from that urban area. Global warming has also increased evaporation rates, again, just because the warmer it is, the faster evaporation occurs. This is just describing the urban heat island effect. So you have an urban area which is going to be absorbing a lot of solar radiation, so it becomes very warm. That means you have more evaporation, and then as that water condenses, then downwind, you'll get more precipitation. Transpiration has also been affected by deforestation. Obviously, if there are less trees in an area, less transpiration is going to happen. And the entire water cycle in the rainforest has been completely altered because of how much deforestation has happened in the rainforest. So yeah, there's essentially way less precipitation surrounding the rainforest and in the rainforest than there used to be. And this has actually led to desertification, which is the formation of deserts in areas that didn't used to be deserts, just because of this. So yeah, we also, because of climate change, are having different types of condensation and precipitation in areas than what we would normally expect. The the changing climate has made the atmosphere less stable. It's weakened our jet stream, which then destabilizes the atmosphere, which means that there's also more like severe weather in terms of precipitation. So more flooding, more hailstorms, stuff like that. Yeah. We've also changed the ocean currents, which we talked about in Science 10, mostly because of the amount of sea ice that's melting, which is making, it's changing the salinity essentially of certain areas of the ocean, which then alters the ocean currents. And ocean currents are one of the main factors that affect global weather patterns. So that has also changed things like condensation and stuff. Runoff is a natural part of the collection process, but due to human activity, like using fertilizers, chemicals, defoliants, stuff like that, all of those chemicals are now getting carried through the runoff and deposited into our watersheds. Agriculture, deforestation, and urbanization all increase the rates of runoff. Agriculture and deforestation, essentially because the soil isn't held in place as much anymore. And then urbanization, essentially you don't have as much water that can sink down into the soil. You can't have as much infiltration. It's all just like runoff through the streets now. Yeah, because of agriculture, things like pesticides, fertilizers, animal waste, and soil contaminants all tend to end up in our watersheds. Fertilizers, as we talked about in both the nitrogen and the phosphorus cycle, can result in algal blooms. Too much soil in the water also decreases water qualities. Pesticides can be toxic to some animals, and animal waste that ends up in the water can contain harmful microorganisms. Acid rain, also an impact of human activity on the water cycle. Essentially, the combustion of fossil fuels releases sulfates and nitrates into the atmosphere. Both sulfates and nitrates can bond with water molecules to form nitric acid and sulfuric acid, which then falls in the form of precipitation back to Earth. That acid rain can harm the soil, plants, and different microorganisms on land. It can actually cause aquatic ecosystems to become dead, like lakes can become dead because they can become so acidic that living things can't survive there anymore. And even before that, usually fish stop laying eggs and stuff like that. And then lastly, we'll talk about water conservation really briefly. In lots of different places, water is being used in a non-sustainable manner. So essentially we're using too much water, which can lead to things like drought, contamination of groundwater, sinkholes, and more. Agriculture is a big cause of this overusage of water. An example of that is in California, where every day human use is causing too much water to be taken out of ecosystems. It's not being replenished, and it has led to major droughts in California. Okay, if you want more information about water conservation, I do have 2 YouTube videos there that you can watch, but they are not mandatory viewing. They're just, I think, interesting videos. Okay, that's it for today.